Doc.
Hey guys.
What's up?
So we're gonna be making a video about soil. So in it, there's gonna be some information about acts and treaties, problems,
Solutions.
controversies.
Exam questions.
Yep. So
everything you need to know.
Stay tuned.
So right now we're going to talk about the soil problems and the soil solutions. So one soil problem is that soil can be too dry. Some soils, such as sandy soils, can be too dry for crops to grow. So the solution for this would be to add compost. This will add both nutrients and increase the water retention capacity of the soil. Sorry for that little mess up. Second, you can have soil that's way too wet. This is usually caused when the compact nature of the soil particles don't allow good drainage of water. One way to stop this problem would be adding sand and pea gravel. Also, because you add these components means you also need to add organic material. This solution will then increase the infiltration of water through the soil. But one thing you must note is that you have to avoid adding sand to clay soils because this will make it like a concrete-like mixture, which will just increase the wetness of the soil. Another soil problem would be that you find that your soil is way too acidic. This is common in areas of high rainfall, poor drainage, heavy nitrogen fertilizer use, and high evergreen tree population. The solution for this is lime, which is to be incorporated into the soil. However, the amount of lime you add is based off of the type of soil you have, so you'll have to do some research. Another soil problem would be if your soil is alkaline. Soils that are alkaline are common in clay soils, arid, and semi-arid climates. The way to balance this would be to add elemental sulfur and iron sulfate at rates dependent on your soil type. However, one thing to note is that elemental sulfur reacts slowly with the soil, so apply it a year before planting. Alkaline soils also require continual buffering, so you must monitor soil pH each year and apply necessary amendment. The last problem with soil is excess salinity. Excess salinity is common to arid and semi-arid climates, low-lying near areas of saltwater. One way to combat this is applying gypsum and elemental sulfur. Two things to note, however, is that you must not apply too much gypsum to sandy or acidic soil since this can cause material deficiencies in plants. Second, elemental sulfur reacts slowly with the soil, so apply it the year before planting.
World climates have changed many times over the last hundreds of millions of years, resulting in dramatic changes to landscape, vegetation, animal life, and of course soil. These changes were caused by a variation in the Earth's orbit in space. The last major climate change was an ice age about 2 million years ago. Over the last 20 years, following the warmest temperatures since recording began, major concerns have emerged that our climate is changing once again, but this time largely due to human activity, particularly to the burning of fossil fuels such as coal and oil. Scientists believe we are now entering a period where the climate change will occur faster than any point in previous time, and these changes will have a huge impact on our soil. Soil has an important impact on the environment. For example, according to the National Research Council, erosion from soil agriculture is responsible for over half of all surface water pollution. Soil is now recognized for its positive impacts on many functions of the ecosystems, such as nutrient recycling, rainfall partitioning, and buffering. However, when it leaves the farm, soil is also responsible for negative impacts that affect water quality, air quality, and wildlife habitats. For over half a century, the U.S. government and farmers have spent billions of dollars for soil conservation on croplands in an effort to reduce soil erosion and reduce impacts on wildlife and water. Because soil quality is related to food production, it can significantly impact human life. There are two further reasons which make soil an appropriate area to focus. First, recent research in soil science has produced a list of measurable soil characteristics that can be used to describe quality of a particular soil. This creates some general consensus about the assessment endpoint of soil quality. Moving on to acts and treaties. The Soil Erosion Act of 1935 was established by the U.S. Soil Conservation Service and mandated the protection of the nation's soil, and it dealt with the soil erosion problems, carried out soil surveys, and did research on soil safety. Another act related with soil is the Soil and Water Conservation Act, SWCA for short. It provided for a continuing appraisal of the U.S. soil, water, and related resources, including fish and wildlife habitats, and a soil and water conservation program to assist landowners. These treaties are really important in keeping up with the quality of soil that is in the United States. The Soil and Water Resource Conservation Act of 1997 appraises the status of soil, water, and related resources and assesses their capability to meet present and future demands. It also evaluates the current and needed programs, policies, and authorities. It is used to develop a national soil and water conservation program. Case studies regarding soil quality occurred in North Bangladesh, one of the world's most densely populated countries. In the 1960s, thousands of wells were dug up in Bangladesh by an attempt for the population to access cleaner water. By doing so, arsenic compounds from the soil began to leach in the groundwater and thus contaminating it. Another case study present in China includes 20% of the farmland in China was polluted, and the arable land in China was contaminated with cadmium, nickel, and arsenic as a result of 3 decades of rapid economic expansion and industrial growth and use of pesticides, which leached soil and thus contaminated arable land. A case study regarding soil quality includes that of the Colorado River Basin. The diversion of the water from the Colorado River led to water right disputes between California, Arizona, and Mexico. The effects were that it reduced nutrient levels in farmlands below the dam, and high levels of salt in the alkaline soil began to be incorporated in agricultural runoff. A recent controversy regarding soil is a recent study scientists have made that says organic crops don't have to grow in soil. Using a growing method called hydroponics, you can grow plants in a watery solution of minerals instead of soil. Since the launch of the National Organic Program in 2000, hydroponic, aeroponic, and aquaponic crops systems have been eligible to use the coveted USDA organic seal on their products. But some organic farmers say that healthy soil is the non-negotiable foundation of organic methods, and for years they have objected to the inclusion of hydroponics in organic certification. Agriculture has always had one major threat looming over it: pests. Potentially ruining a harvest, farmers are obliged to take action against pests. There are various methods to combat the problems and various advantages and disadvantages to each method. One way to protect crops is to use chemical pesticides. A chemical pesticide is used to control, repel, attract, or kill pests. For example, insects and weeds are considered a common pest or threat to kill crops. Pesticides are most often, not always, poisonous. Thus, farmers must be careful not to overuse chemical pesticides, as they might cause harm and side effects to non-target organisms, especially people. It's not only people that are affected by pesticides, but also the environment. Pesticides kill not only the pests, but also the natural enemies of these pests, a problem known as resurgence. Resurgence means that the natural control of pests is disrupted severely and crops suffer as a result. Resurgence can create new problems. Minor pests that are usually kept at low numbers will multiply quickly in the absence of their enemies. The most popular opinion in this problem is an often used alternative method to chemical pesticides: biological control. Treatment of soil with pesticides can cause populations of beneficial soil microorganisms to decline. Overuse of chemical fertilizers and pesticides has an effect on the soil organisms that are similar to human overuse of antibiotics. Indiscriminate use of chemicals might work for a few years, but after a while, there aren't enough beneficial soil organisms to hold on to the nutrients that are important for the soil.
Okay guys, now it's time to talk about questions. That's right, questions that you could see on a possible AP exam, a test, or a quiz. So let's get started. One question could be, what soil is coarse and drains quickly? And you may have to choose from sand, clay, loam, or silt. But you know what that answer is? That answer is sand. Moving on. What soil is red and brown in color and holds water? And you may have to choose from sand, clay, igneous rock, or humus. But that answer is clay. Another question could be, what soil is a mixture of humus, silt, sand, and clay? And you may have to choose from answers such as sand, silt, loam, or clay. But that answer is loam. Now, what if you're taking a test and it asks for definitions? Well, here's some examples. One example could be the accumulation of salts in soil in a process that is harmful to plants. And that answer would be salinization. Another definition question could be the result of soil degradation and absence of vegetation in arid and semi-arid areas. Well, that definition, that's for the word desertification. Now, another one is the process of humus in soil particles being picked up and carried away by water and wind. Well, that answer is soil erosion. Lastly, if it asks you to list all of the soil horizons, you would say O, A, E, B, C, and R. But wait, what if it asks you to list each component? Well, this is what you would say. O has organic matter. A is topsoil. E is leaching layer. B is subsoil. C is weathering bedrock. And R is just bedrock.